Hi everyone, welcome to this video series on word embedding. We are focusing on Word2Vec algorithm. In this particular video, I'll walk you through some of the use cases or demonstrations using Gensim and Word2Vec in Gensim and doing text classification. So there will be four different use cases, although they're going to be very small demo. Let's get started. Yeah, the first demo is with the dummy data, and I'm going to be using a continuous bag of word model. And for that, TensorFlow. So let's run some of the packages here: sequential, embedding, dense, lambda, and flatten. Tokenizer for tokenizing the data. So we have here some dummy data here and 20 sentences. We will tokenize those using tokenizer package. Fit on text will actually create the vocabulary, and you can take a look at the vocabulary by saying tokenizer dot index word. That means for each of the index, what is the word associated here. So index is going to start with 1, not with 0. That's the key difference here. Word count, how many words total we have here. And notice Kara's index actually starts with 1. So in order to know the number of words, just add 1 to it, and that will be total number of words in your vocabulary. We're going to use the continuous bag of word implementation where the input is the context word and the output or the target is being predicted or center word is being predicted. So that means from our data, from our dummy data, we would like to create the training pairs or training data. Let's make an assumption the window size is 3 and just a little code here which will actually prepare our continuous bag of word pairs which we can use for training. So there are about 900 samples from the 20 samples that we have. And then you can get the from the pair. So this is basically a dictionary and extract the words and the target words. The first one is the context and second one is the target. So for example, here, this is the context and this is the target. This is the context, this is the target. And like this, you have generated the pairs of training samples. For example, here, if it is 1, that means the index of 1 is the context and the predicted word or the word to be predicted is index 3. So we can analyze the pairs. I just provided a little bit of code here and you can analyze here how the pairs are being created by using the window size of 3. Now what we're going to do is we'll set up the embedding layer along with the model specification. So this is my embedding layer. We have to tell how many words in our vocabulary and what is the embedding size. Input length is going to be 1. That means a sample at a time will have only one word coming to the model, unlike the regular text processing where you have one sample consisting of 100 words. This is not the case here. One sample, one word. So this is my model. And finally, softmax function for predicting the probability of every or each of the vocabulary word here. And one of the word will have the maximum probability. And then we're going to use the sparse categorical entropy here, cross entropy, because we're not using the one hot encoding. We use simply the classes here. So we use the sparse categorical cross entropy, and then you fit the model. It's going to take a little while to train. So what I'm going to do, I've already trained it. So let's look at the outcome of the training here. So get the weights from the model, and then let's say you are interested in knowing the embeddings learned by the model for the token machine learning and algorithm. So these are the embeddings here. You can also plot all the tokens that we have in our model. And since this is two dimension, which is really not a true or true reflection of the, the reflection of the, vector representation. But just for visualization purpose, two dimension is is the only way that we can actually use. So in this case, if you take a look at some of the words like artificial and intelligence, if you look at the angle here, is pretty small. That means the vector representation is also similar. Even my name appears here, and along with it, the word trainer should be somewhere. I'm not able to find, but since we used Bhupen and trainer together, so presumably the vector representation should also be similar. Or you can verify that by taking a cosine similarity between the embeddings for Bhupen and trainer, that is showing 0.99. That means the vectors are indeed similar in terms of the representation. And even the word Bhupen and machine also exhibit quite a high score. That means they have similar vector. So this was with the dummy data. Let's take a look at another example, which is more comprehensive and lots of data there. Now, in this example, I'm going to be using a Brown package or data package, which comes with NLTK. And I'm going to use Word2Vec library in Gensim package. And there are some parameters. So these parameters are, so let me show you. The first one is the sentences. You need to pass the input data to this variable, mention the window size, or rather the embedding size. So this is embedding size. Let's say the embedding size is 100 or 200 or 50, whatever that we are targeting here. This is the window size. You typically set it to 3, 4, or 5. Default is 5. Minimum count is parameter which tells Word2Vec that don't consider any token which appears less than the minimum count. Number of iterations is the number of epochs that the model actually should run and train itself. So the NLTK package and the Brown here, Brown is a corpus, and you download the corpus and look at all the sentences from the Brown corpus. There are 57,000 sentences. That's really high. And in order to train a Word2Vec model using so many sentences, it's going to take time. So I've already trained it. Here, provide the sentences, all the sentences, mention the dimension size and the window size. I kept it 5 as a default, but you can change it. Minimum count, this is again a parameter that needs to be set after quite a few experimentations. Epochs, I've kept it at a low. Usually it is set to 100 or 200 or even 1,000. So after training, you can look at the word vector for the word love. This is the embedding or vector representation for the word love. Now, Gensim package provides quite a few useful functions. Let's say you want to find out the most similar embeddings to the word cycle. It's going to return those, let's say, the registration, nights, and mucosa as the closest representation to cycle. You might as well want to do some kind of a plotting using two-dimensional, visualization for these words. And the interesting thing is, again, you see, look at the embedding for the teacher and the student is pretty aligned. The angle between them is very small. That means the representations are quite similar. I hope this example was more interesting and more compact using Gensim package and creating the embedding. Yeah, welcome now again to the third example now using Word2Vec. And this time we will use another data set. And this data set can be found in this link here. It's a automobile data, and I have it here in this location. Um, you should be able to access this location as well when you run the code. And the dataset has columns like make, model, year, engine, fuel type, and so on and so forth. Out of all these columns, we will target the column which are text in nature. And then on those text column, we'll apply Word2Vec. So make column and model column, make and model, they look to have the textual data. So we combine those and create another column here. And after that, on that column, we will be creating the Word2Vec. So essentially, we combine all of them, and this is how the data, combined data that looks like here. So on this data, we can apply Word2Vec. So in order to do a Word2Vec, it has to be in this format, which is a list of list format. So convert that column data into a list of list format. Now the process remains the same. Use Gensim Word2Vec, provide the size, which is the embedding size. Default is 100. You can use any setting that you would like to target. Window size is again configurable, 3, 4, or 5. Minimum count as per the requirement. And workers is if you have multi CPU, then you can make use of the workers parameter. Now, Gensim Word2Vec also provides you with another parameter called skipgram. If you turn it, if you want skipgram, then set it to 1 or otherwise 0. So if skipgram is 0, that means it's going to use continuous bag of word implementation. So configure the Word2Vec model, and then after that, look at the data. This is the data here. Get the embeddings as we have done in the previous example. So this is exactly the word that you have to type, BMW Z8 and Z8, and this is the embedding here. And you can also find similarities between two different words. Sorry, let me just, yeah, so this is the similarity between these two words. And these two cars, I mean, there's high similarity. Similarly here, Hyundai Accent and Mercedes again shows high similarity here. So like in the previous example, you can also generate the most similar tokens or phrases. So let's say if this is the given phrase and you would like to know the most similar embeddings or tokens to Mercedes-Benz top 5. So this is what is the return. This is very quite useful um, analysis. Similarly, Toyota Camry, you want to know the closest cars to Toyota Camry, and you notice here the output for Mercedes, similar to Mercedes and similar to Toyota Camry, they look different. So that was another example how we can actually use Word2Vec embeddings in the real NLP application. The last demo that I'm going to show you is how to use a pre-trained Word2Vec model for doing text classification. In this example, I'm going to show you how to use a pre-trained Word2Vec, which is called Glove vectors, in performing text classification. In the previous example, what we have looked at was generate the word embedding and look at those embeddings in terms of plot and also find out the most similar, embeddings and so on and so forth. This is a real application of one more real application of using the pre-trained model for text classification. Again, I'll be using some dummy data for sake of time. In order to really apply to real world data is going to take significant amount of time. So this is again TensorFlow and Keras basic model and some dummy data, positive reviews and negative reviews, and accordingly the labels are also given like 111 000. And then tokenizer as usual, like in the previous example, the Keras tokenizer and fit on text will create the vocabulary. Or we need to add 1 to it because the Keras tokenizer does not start with 0. So you have to add 1 to the count index so you know what is the number of tokens that you have. So that's 45 here in this case. So the embedded sentences after the tokenization, the first sentence looks like this, and you notice how Keras is assigning the integers randomly to those tokens. And these samples are of variable length. For example, here there are only 2 words. Oh, probably this is the one has 2 words here. So we need to standardize it in terms of, let's say, each sample should be a length of, 10 or something. So we can set that up using the, um, some variable, and that will standardize all the samples to have a similar length. Now we need to download the pre-trained model from the website, and there are lots of websites, and I'll post the link to the Google website from where you can download the globe vectors. I've already downloaded it here. It is, I think, it's a size of maybe 10 MB or something. I don't exactly recall, but it's pretty big. And this is only 100 dimension vector. Now, what we need to do, this vector is in a text file format. That means the vector would be somewhat like this. Let's say the word is ABC and then the colon, and after that, the embedding. Next word, let's say W1, and again, the embedding. So this is how the text file is actually uh, in this particular file, the content will look like exactly that. So you need to read each line, then split it here, and after splitting, take the first one as the word and put it in a dictionary. So essentially, we need to convert the format into a dictionary format. So once we have done that dictionary format, then from the dictionary, we will have to convert it to a list of list format required for Keras. So another, translation from the dictionary to the list of list format. Now you look at embedding matrix, it is just list of list format, and this is how the data has to be presented to the model. Sequential is your, functional call, and then the layer, embedding layer, input dimension is the vocabulary length. Output dimension is, whatever dimension that we want to have for each of the token. Let's say 100. And this is the new thing that you're seeing here. The weights are not going to be learned by this model, but the weights are going to be reused from the pre-trained model. So we have downloaded that and we have maintained that pre-trained model in this particular variable. So we need to provide that here. And then input length is the length of the sample here. Trainable is also should be set to false. We don't want to train the pre-trained weights here. We want to use it here. And after that, add the embedding layer, flatten it, and then finally the classification. This is pretty much what we have to do when we have to leverage or reuse the pre-trained model in our text classification exercises. This is another example. This is also an example of a transfer learning. I hope this example was useful. With this couple of Python code, I am sure now you're comfortable with the idea of Word2Vec and how we can use Word2Vec model or function in Gensim, and what are the typical use cases of word embedding. So essentially, we have covered the demo on Word2Vec using dummy data. We have covered some use cases of Word2Vec provided by Gensim. We've also done some text classification example using a pre-trained model. In the next video, we will look at the optimization requirements for Word2Vec. There are some concerns with Word2Vec in terms of computational overhead, and there are some solutions, how we can, what those solutions are, and how we can use those solutions uh, to, to really improve the training part of the Word2Vec. Thank you all. We'll see you in the next lecture.